This is a magnoflux experiment to show you that a normal induction motor, and this one was taken out of an old washing machine, the drain motor in fact, is totally magnetic. The movement of the energy through the motor is totally magnetic and is not really to do with electrons. Let me just show you what's going to happen when we start the motor. So we switch on the motor, immediately get about 0.9 amps on the primary winding and 11.5 on the secondary or the teaser winding here that's making it soft. If we now jam the motor, then up goes the secondary to about 12 and about 1.1 on the primary winding. But let me now unplug it again. And if we take it away now, the magnetism's gone out of here. But all that is in here is one winding, the main winding there, which all the electrons and things go round, but the whole of the power is in the magnet itself. There's no connection between the electrons in the primary winding and the secondary. It's only the magnons in this core that are carrying the whole of the energy. So energy is carried by magnons, and at the heart of the magnon is the magnoflux area. So it's to do with the flux. If we then look at the drawing behind, which I think you can see quite clearly there. So the main winding here, the 240 volt winding, is there. So the electrons you think were just rushing around in the corners there. But the whole of the power has to come through the magnons, which are in the magnetic core. And of course, once we jam that rotor, then that completed the magnetic path, and the only thing in the secondary then is the teaser winding, or the winding that is shading the pole. And of course there's a big gap, air gap there, which is stopping it from doing anything else. So the main point of this is to point out that electricity, because it moves at the speed of the light, it's the magnons that move at the speed of the light and not the electrons, and therefore electricity is a very low frequency light. That's all I needed to tell you. Thank you very much.